So I don't even think you need to take notes today, but I do need you watching and paying attention. So today we're doing 8-2, and what we're doing is instead of simplifying trig identities, we're going to be verifying trig identities. So before, notice, as you went around the room, which was reviewing what we learned last time, you were only given this. For example, secant squared theta minus 1 over secant squared theta simplifies to be what? You went through the algebra and you came up with sine squared theta. So today the only difference is they're going to give you both sides of the equation and say, prove that this side does indeed equal this side. So it's almost easier, right? It's the exact same thing. Yeah. Except for it's almost easier because you know exactly where the ending should be. Does that make sense, everybody? Okay, awesome. So let's do an example. Maybe we should start with that one. That's what this says. This equals this. Yeah, they will ask that. Is this true? Yes or no? And then you have to put yes or no. Good point. Good question. Okay, let's go through maybe this one. So, what we're going to do, guys, is let me give you a hint. So you're going to start on this side of the equation because it's the messy one. Correct, everybody? It's usually easier to take a messy one and make it unmessy than something unmessy and make it messy. Does that make sense, everybody? So, any suggestions on how I should tackle this? Yes? Perfect. That's exactly where we're going to go with this. Split this one up. Paying attention over here. So, secant squared theta over secant squared theta minus 1 over secant squared theta. That is absolutely true. So, this is how I would want to see your work. So, now what does this become? 1 minus, what does that become? You do know. Right away, what's the reciprocal of secant, Dylan? Cosine. So this is cosine squared theta. What trig identity is that? Sine squared theta. And now we know we're done, because check, check. We got there. Everybody understand what you would be expected to show? Pretty easy. Like I said, where I forbid you to use your book yesterday, it really pushed you to get to know your stuff and see where you're going, so it should be easy. Hey, look. Which side should we start with? This one's definitely more messy, correct? What should we do? Good thought, but not exactly quite where we should go. What's our goal, though? You're right, we are going to be multiplying by the conjugate, so you weren't completely wrong, but what are we trying to do? Common denominator. So we're going to multiply this by 1 plus sine of theta. That's what I just said. You wasn't completely wrong, right? So 1 plus sine of theta. And then over here, we're going to multiply by 1 minus, but what we were doing is getting a common denominator, which happened to be the conjugate, so that wasn't great. Does that make sense? 1 minus sine of theta. 1 minus 1. So then right here, what do we distribute? 1 plus sine of theta over, what's the bottom going to be? Just quick. 1 minus sine squared theta. What is that? Cosine squared theta. Good. Rebecca's seeing it. Is it cosine squared theta, guys? Yeah. So then plus, we distribute this. 1 minus sine of theta over cosine squared theta. Because 1 times 1 is 1, right? Middle terms cancel out, so we do not need to distribute the middle terms. This times this is negative sine squared theta. Isn't that a trig identity? Cosine squared theta. But we should be getting these memorized at this point. So now what can I do? Combine them. So we have what on top? Quickly, guys. These should be quick. 2. What's on bottom? Cosine squared theta, which is 2 times 1 over cosine theta, right? Which is 2 secant squared theta. Did I end up where I was supposed to end up? Questions on that? So this is pretty easy, right? So we don't need to keep going with this? You're good? I don't want to waste your homework time. You good? Okay, I want to talk about this one. Everybody look up here. So, recall from algebra that rationalizing the denominator of a fraction by by multiplying by the conjugate can be a powerful simplification technique. So everybody look. If we have 1 over 1 minus the square root of x, we can take that and multiply by the conjugate, which is a change of sign in between, correct? So we multiply by 1 plus the square root of x to top and bottom, because then we're only multiplying by a fancy 1, correct? We're not changing the problem. And then it would simplify. So we're going to extend that idea to something like this, which you already know all this. This is what we learned yesterday. So if they're saying to us, prove that this side equals this side, what I want you to notice is that this side would be considered unfavorable. Why? Because there's fractions, which are above all the least favorable for calculus, right? Which is what we're doing here. We're getting prepared to go to calculus and have things be in better formats. So everybody, I would use this side and go this way. So what should we multiply to get this to be able to undo here? The conjugate, because it's not squared, right? The only way to make it squared is to multiply by sign, but we don't want the extra sign in there. So we multiply by 1 plus sine of y, right? 1 plus sine of y. And then from there, the simplification can go 10 different ways. So on top, we would have cosine of y times 1 plus sine of y, correct? And on bottom, we would have 1 minus sine squared y. Now, I'm going to ask... Yep, perfect. Way to remember that identity. So this is the same thing as cosine squared y. So look, notice how I didn't multiply the top in. I just was waiting to see what happened on bottom before I did that. Now on bottom I had cosine squared y. So now what can I do, guys? Cancel out a cosine. Very good. Now is it on bottom or top? Bottom. So now still not a very pretty answer so far. Well, there's fractions, which is the least favorable. So what should I do here? Separate them again, right? Guys, separate them again. 1 over cosine of y plus sine of y over cosine of y. So secant y plus tangent y. Does everybody understand? Dylan went really fast through that. Everybody good? Okay, good. Okay, perfect. That's it, guys. Literally the same thing. Even though it's a whole different section in the pre-calc book, it's that easy. We started with the hard stuff. Now it's super easy. Yep. Go for it.